Welcome. Let's try to solve another Leetcode problem. 35, search in third position. So we are giving a sorted array nums and we are giving a value target. We just need to find the value target. If it is inside the array, we just need to return the position of the target. So for this example, it's going to be 2. If it is not inside, we need to find where we're going to insert it. So in the second example, it's going to insert at position index 1. So this is why we're going to return a 1. For the third example, it is 7. So this means we're going to insert at position 0, 1, 2, 3, 4. So it means it's going to be at position 4. Yeah. So we need to solve it by using log n time complexity. So this means we're going to use the boundary search to solve the problem. And nums contains distinct values sorted in ascending order. So this means yeah, the problem gonna be easier because all the numbers are gonna be unique. So we can directly use boundary search. So for boundary search, we're gonna define two numbers. Let's define L starting from 0 and another integer gonna be R. We're gonna define it as nums.length minus 1. Now we can directly use the template to solve the problem. While L less than or equal to R, we're gonna define integer m, which is gonna be L plus R minus L divided by 2. Yeah. Now the condition is that we just need to check the value at m. So if so we're gonna check the value. If this value is more than target, yeah. So let's just make a drawing. So this is a drawing. So for example, this value is the target. So this is m. Yeah. If at this position, at mid position, this value, if maybe m is here. If it is if this value is more than the target, so this means yeah, so this means at the right side all the numbers need to be removed. So this means it's going to be r going to equal to m minus 1, else L going to be m plus 1. Finally, we're going to return L. So this is our basic template. We just need to know how to write the boundary search template to solve the problem. Now let me just run it. Oh, it didn't work. Let me check it. So for this number 5, we need to return 2. But for me, I return 3. Yeah, it's going to be at this position 2. Did I do something wrong? So we're going to use more than equal. Yeah, we need to use more than and equal. Yeah, sometimes we're going to check if yeah, because we need to find this number. So for example, this 5 is going to be more than the 3. It's going to be at this place. Yeah, or we can use another way to write it. But I think this is easy way to write. So let me just make the drawing to check why we're gonna use this way. Yeah. So for example, this is 1, 3, 5, and 6. And m is at this position. The number is 3. So this value, if it is less than target, target is 5. So this means L gonna be updated at this position 5. So this is L and this is R. And then we're gonna check the m. So m gonna be at this position 5. Yeah. So if this value nums m more than and equal to target, so R gonna be m minus 1. So R gonna be here. And we're gonna go out of the loop and we're gonna return L, which is gonna be this value 5. So this is why we're gonna use equal. Yeah, but if we don't use equal, nums m, if nums m at this position, it is 5. 5 is not more than 5. So what are we gonna do? Yeah, so we're gonna, so if nums m is more than target, but currently it is not more than, it is less than equal. So this means we're gonna update L. So L gonna be updated at this position, at this number 6, and then it will go out of the while loop. So definitely it is wrong, because we need to find the value which is equal, and we need to let the right pointer go to the left side instead of the left pointer go to the right side. So this is called lower bound. Yeah. So we need to find this value. So for example, it's going to be more than or equal to this number. It's going to be at this position. This is the lower bound. So we need to check the equal. So if nums m is more than or equal to target, we're going to update this R pointer. So sometimes we forget about it, just make a drawing and to make it right. Yeah. Now let me just submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is log n. Maybe you want to use a safe way to solve it, so we can use it this way. So if nums m is more than or equal to target, and else, here we're gonna use else if nums m is less than target, we're gonna update the L border. But else, that's gonna be another condition. So this means nums m gonna equal to the target. So this means we can directly return m. Yeah. This means we've already found it. Yeah. Otherwise, we're gonna find the place and where we're gonna insert it. We're gonna return L. Yeah. So now let me just run it. Now it works. As you can see, it works. Yeah. Yeah. So anyway, it will work. Maybe you think, why not just return R instead of L? But this is going to be wrong, I think. Yeah, as you can see, it's wrong. Because finally, how can we go out of the while loop? So this is L, this is R. L going to always less than or equal to R. So finally, R going to be at the left side of L. Definitely, it's going to be wrong. And this number going to be wrong. Finally, we're going to return the pointer L. So this is the idea why we're going to return L. Yeah. Now let me just prove it. Yeah. Yeah. So anyway, you can write it. Maybe this is the easiest way to write. Yeah. I think that's all about it. Thanks for watching. See you next time. I think it works.